Hey everybody, Mr. Smith here, shooting a video in my bedroom, talking about combining all of the transformations together. So first thing what we're going to do is we're just going to get a summary of all the different types of transformations that we have. Um, so let's just get that done. And this is will just be a nice little resource for you. So the first thing we saw / reviewed was that a transformation, like when we're adding or subtracting a number off the end, is a vertical translation. And if C is greater than 0, translation is up. If C is less than 0, translation is down. If you in your own notes, if you have, if you can, dots are okay or point form is okay. And in terms of how the ordered pairs are mapped, if something is shifted up by C units, that means the Y value is being increased by C. So Y plus C. And this works whether C is positive or negative. Right, let's continue. And then in the same lesson, we looked at horizontal translations. Now, if D is greater than 0, meaning you're subtracting a positive, so like x minus 2 or x minus 3, the translation is to the right. If D is less than 0, the translation is left. And in these cases, the transformation is as follows. The x value is being transformed, and we're adding whatever D is onto it. So this is kind of the counterintuitive bit, but we have seen, like, for example, y equals, say, x minus 2 squared. We know it goes right 2 units, right? And so if we're moving right 2 units, it means we're adding that value of D onto the x. I've got reflections next. Reflections were actually we did those last, but let's get these on here. So we saw that when we had a negative in front of the whole function, that was a reflection in the x-axis. So it was like a vertical reflection. Let's get all these guys down. When the negative is on the x, we saw this was a reflection in the y-axis. And it is possible to have both. Not sure if this merits its own slot, but this is a reflection in both x and y axis. And we saw that, if you're reflecting in the y-axis, in the x-axis, then that means that the x value stays unchanged and you're flipping the sign of the y value. And if you're flipping in the y-axis, then you're changing the sign of the x value. And if you're reflecting in both, then you're changing the sign of both. And we had stretches / compressions. So y equals a times f of x, multiplying the function by a number out front. And I should say too that in this we're just thinking a is greater than 0 right now, because when a is negative, we have a separate transformation for the negative. It's a reflection. So we'll just consider when a is greater than 0. So this is a vertical stretch / reflection. If a is greater than 1, it is a vertical stretch. If a is between 0 and 1, then it is a horizontal stretch. Excuse me. That is totally wrong on both. It is a vertical compression. I might add, it's a vertical stretch by a factor of a. aniline. Fit nicely. And that's like the long-winded version. So if you can simplify that for your own notes, a little dot jot or point form, that's totally fine. And the transformation was quite simple here in terms of the mapping notation. It's a vertical stretch or compression. So the X value is unchanged and the Y value is you're just scaling it up by whatever A is. And, this brings us to maybe aside from reflecting because last year you guys did parabolas that opened up and you did reflect them down, so they opened downwards. You kind of had seen reflections before, maybe not horizontal reflections. You definitely didn't do horizontal stretches or compressions last year. So let's summarize this last one. This is a horizontal stretch. Oh my goodness. So I bet many of you guys are screaming at the monitor. Vertical stretch or compression. There we go. A horizontal stretch or compression. Okay, so we saw that if K is greater than 1, then it is a horizontal compression by a factor of 1 over K. If K was between 0 and 1, then it is a horizontal stretch by a factor of 1 over K. And that took a bit of getting used to. But in these cases, what happens is the Y value stays the same, and you're multiplying the X value by the reciprocal of K. So if it was, say, F at 2X, that is actually a horizontal compression. And we don't say compression by a factor of 2. Factor of 2 indicates you're kind of doubling something. We would take that reciprocal and say by a factor of a half. So the X values are halved, resulting in everything getting squishier to the Y-axis. And the class I'm doing right now, we did some exercises and some warm-ups showing that the order of transformations is important when you're mixing in translations and reflections or stretches. I just noticed too, I might add in here that K is positive here because we've already dealt with when it's negative. But I want to add a little note here is that you must apply stretches / reflections first before you apply translations. There's an easy way to think of what you do first. When you're doing order of operations, BEDMAS, you always do multiplication before addition and subtraction. And so if you look at all these transformations we have, stretches and reflections all involve multiplying the X or Y value by a number, and the translations involve adding or subtracting. So it's always multiplication before division, just like in BEDMAS. So stretches, reflections first. So what we're going to do today is we're going to graph some functions that have everything going on. They've got a number out front. They've got a number adding on the end. They've got a number subtracting the X. They've got a number multiplying the X. They have everything. And so we're going to have to be able to pick off all those values so we know what transformations to do. And so the rest of this lesson is just getting a bit of practice. So here's what I've developed as I've taught this course several times. I've developed this as a little bit of a just a tool to help initially students with sketching. I just noticed here the X plus D, Y plus C, that's just a little off in the cell, but that's okay. It still works. So when you're given a function, first of all, you have to recognize what your base function is. You have to know what you're transforming. So in these two first exercises, I've just given you some piecewise defined function we'll just use. And I've given you the original points. We got -3, 0, -1, -2, 1, 2, and 3, 2. And let's just pick off the transformation. So we've got a lot of things going on here. So what do we got? I might zoom in a little bit just to fill my screen up here. That looks good. All right. So I always look for C and D first. So on the end, C is -2. That's the number on the end. Careful with D. What are we subtracting off X? We are subtracting +2. You got to switch that. What's A? What's being multiplied out front? Well, that's a negative, so A is -1. And what's K? Is there anything specifically multiplying the X? No. Does that mean K is 0? No, of course not, because there would be no X there, right? 0 times X would be 0. K is equal to 1, and that would make 1 over K. 1 over 1 is also equal to 1. So pick off those things first, because then if you can do that and you're careful about it, and you get those accurate values, it's easy to transform the function. So I'm going to switch back to black here. So take your originals, and as I mentioned, you apply the stretches and reflections first. So that involves multiplying the X by 1 over K and the Y by A. And in this case, notice that, if A has a negative, that will include the reflection. If K has a negative, that will include the reflection. So the stretches and reflections all tie in together. So yeah, let's do it. So -3, 0. So we're multiplying the X values just by 1. That's easy. And the Y values by -1. Oh, that's pretty easy too. So X value by 1, -1, and then basically switching the sign on the X value. So again, we're applying our transformation. We're multiplying the X values by 1 over K and the Y values by A. Is this the be all and end all tool? No, but I found at least it helps a little bit. It helps people get organized. It's definitely not a perfect system, but it helps me, and I found it helps students do pretty well with this. And then -2, and then 3 and -2. Okay, now you may at this point, you may find value in possibly sketching that function. You don't have to, but maybe we'll do it for this first one. So -3, 0, -1, 2. Of course, 0, 0 is invariant. 1, -2, and there. And so maybe I'll just do a dashed line. I don't like to add too much. I don't want to get it cluttered. But you can see we've applied the reflection, right? Basically, all that happened there is we've just got that vertical reflection, right? Negative out front. There was no horizontal reflection or stretch, no vertical stretch either. Everything was 1. And now we do the translating, which is not too bad. So we're going to add 2 to the X values, and we'll subtract 2 from the Y values. Or essentially, you're just picking all these points up and moving them right 2 and down 2. So adding 2, -1, subtracting 2, -2, adding 2, 1, subtracting 2, 0, adding 2 is 3, subtracting 2 is -4. That doesn't seem right. Oh, yeah, we're down there. We're good. Adding 2 is 5, subtracting 2 is -4. Now I will switch to a different color. And if you're working in Cami or printing it off at home, using color is not a bad idea. So now I'm taking all those reflected points and moving them right 2 and down 2. So I get to -1, -2. Get to 1, 0. 3, -4. 5, -4. So I reflected it first, and then I translated that. And that's how I kind of approach these things with a bit of structure. Eventually, we'll have to be able to do this without any structure, but this is just a good building block. So pick off your values, identify your points. In this case, I gave them to you. Do stretches, reflections first, and then translate. So why don't you try this one? Maybe you want to just, at the very least, pick off your parameters, pause the video, unpause when you're ready. I'll assume you've done that. So looking at k, we have a k value here. We're multiplying x by negative 2. 1 over negative 2 is negative a half. Value out front, negative 2. Value of d, we are adding 1, which is like subtracting negative 1. We're always switching that on the x, and then nothing on the outside. C is equal to 0. Let's reflect first. So we're multiplying our x values by negative a half. We're multiplying our y values by negative 2. So we're having these guys and doubling these guys and switching the signs at the same time. So 0.5 and positive 1. So again, we're doubling this one actually. So that should be 4. Having the x value, making it negative. Double the y value, make it negative. So I'm just applying our rule, just doing some multiplying. Having the x value, making it negative. Doubling the y value, switching its sign, making it negative. So I'm just going to plot those just to make sure that everything looks okay. Catch any mistakes possibly. 1.50, 0.54, negative 0.5, negative 4, and negative 1.5, negative 4. And again, 0, 0 is invariant to these. So I'm just going to take a quick look. Does the shape look like I've reflected it vertically? Yes. And horizontally? Yes. And I've got a vertical stretch. I can see it being stretched out, but I can see all the x values being compressed. So everything looks decent. And now it's translated. This is a bit easier because we're basically just subtracting 1 off the x values and doing nothing to the y values. So 0.50, negative 0.54, negative 1.54, negative 2.54. And I'll use pink for my final color here. 0.50, negative 0.54. This is a bit easier and can probably be done, for many of you guys. You could probably just, I should be in pink. Why am I not in pink? There we go. This guy's here. This guy's here. So we're just picking up all these points and moving them one. I think everybody here could just visually do that, but I just like getting the points too. Just a good double check. And then that is goes here, negative 1.54. That should be negative 4 because we weren't changing the y value. And negative 2.5, negative 4. Copying error there. So I like having the points because I can it's just another check, and I make lots of errors, especially tonight. Taught all day, did a couple hours of prep, play with my kids, put them to bed, and now I'm shooting a video for you guys. So I'm definitely not at my sharpest, but that looks pretty good. Now, guys, I gave you the base function here. I just drew a sketch of it. What you guys have to be able to do is actually pick off these parameters when you have an actual function like we've been working with. So at least initially here, I've tried to help you guys out by sketching the base function. So our base function here is the radical function, and it's 4 key points. I have their originals, and I've sketched the original graph. But in practice, that's something you guys can do. I'm doing it here because I want to get a lot of examples in and just get you guys comfortable applying all the transformations. So let's look at the equation. What do we got? So D opposite, negative 5. C, keep it, negative 4. So we're going left 5, down 4. Are we multiplying the entire function by something? Yes, there's a negative 1 all out in front there. So that's negative 1. And are we multiplying the x by anything? No. So that's just 1. So that's always nice. All right, So let's do our reflections and stretches. This one's not so bad. All we're doing is changing the sign of the y value. 0, 0, 1 minus 1, 4 minus 2, 9 minus 3. All that's going on with K and A is just a vertical reflection, a reflection in the x-axis. 9, negative 3, maybe make a dashed line, little intermediate step there. And now we'll translate everything. So we're going left 5, so we're subtracting 5 and subtracting 4. So negative 5, negative 4, negative 4, negative 5, subtracting 5, negative 1, subtracting 4, negative 6, and then subtracting 5, 4, and subtracting 4, negative 7, I believe. And then when I plot these, I better have the same shape as my dashed function here. Otherwise, I can go back and check my mistakes. So minus 5, minus 4, boom. Minus 4, minus 5, that's good, same shape. Minus 1, minus 6, that's good, same shape. And 4 minus 7. Yeah, it looks good, same shape. Now, so it starts here and continues on like that. So starting point here, like there's nothing to the left of that. That's where it starts. So that wasn't so bad. But again, yeah, you guys in practice are going to have to get to the point where you can get the original points and you can sketch the base function. I did it here, though. Let's try another radical one. Do you want to try this one on your own? Pause the video maybe and give this one a try. Just try. You can do it. What's the worst that can happen? You make a mistake and you learn from it. How many mistakes have I made already today, right? Counting school, probably like 10. At least. All right, so I'm going to assume you guys have unpaused it. So let's pick this stuff off. D, the opposite of that, positive 3. C, positive 2. Am I multiplying out front by anything? No. A is 1. Am I multiplying the x by something? Yes. Negative a half. Now, 1 over k, that's the reciprocal. We're just flipping that. It's negative 2. 1 divided by negative a half is negative 2. And now let's apply our stretches / reflections, all encompassed together in this 1 over k and a value. We can see that, from just talking about our transformations earlier, we can see we have a reflection in the y-axis, and it'll be a horizontal stretch, which makes sense, is why we're doing the negative and multiplying the x values by 2. Nothing for the y values. All right, so 0, 0, and then negative 2, 1, negative 8, 2, and negative 18, 3. Once in a while, a transformed point might be off our graph, and that's okay. And then we move things right 3. Oh, let's actually sketch this. So 0, 0, minus 2, 1, and minus 8, 2. And I'll just do a dashed line. So definitely looks like it's been reflected horizontally and stretched. Everything's fitting. Let's translate this now. So adding 3, adding 2, 1, 3, negative 5, 4, and negative 15, 5, which will be off our graph, but that's okay. And so we get 3, 2. 0, 0 goes to 3, 2. And we want the same shape, 1, 3. Yep, that's the same shape as our dashed one. Negative 5, positive 4, same shape. And again, negative 15, 5, somewhere around here, but doesn't quite fit in the graph. And just do your best. Just draw the function in there. All right, very nice. So, hopefully you're kind of getting the idea. let's do a couple more. So we're going to this time do the irrational function. We haven't done that in a while. So I've sketched the originals, but again, I would fully expect you guys to recognize, hey, this function, the base is, I can see an x in the denominator. It's the 1 over x function. And I've used these 4 key points. I think they're kind of easiest to work with. And I've graphed them all there for you guys. Aren't I nice? So let's try to pick off our parameters. So what's off of the x? -3. Switch it. D is 3. What's on the end? Adding, subtracting, -2. All right. What are we multiplying the entire function by? Or like, so that's maybe a bit harder to see here. Maybe we'll even start with k. Is there anything directly multiplying the x? No. K is 1. So 1 over that is 1. And this is where the 2 comes in. You know, if I had f of x equals 2 over x, that's like 2 times 1 over x, right? And that 2 would appear in the numerator, so that our a value is represented by this 2 here. A is equal to 2. And now that we've picked those guys off, let's transform. X values stay the same, y values double. Nice. Doesn't seem too complicated. 0.54, 1, 2, negative 0.5, negative 4, and negative 1, negative 2. Let's just plot those. 0.54, 1, 2, negative 1, negative 2, and negative 0.5, negative 4. And do some dashes. Something like that. Again, something like that. Now notice when you do stretches and reflections, remember things on the axes were invariant. So the asymptotes, which are on the axes for this function, don't move during a stretch or reflection. Now they're going to move. We're doing a translation. So before I even get these other points, we're shifting everything to the right 3, including the asymptote. So why not just draw? I might just use a really bright color to illustrate this. Why not draw in the new asymptotes? So right 3, and then we're shifting everything down 2. So the horizontal one will be down 2. And then everything should fit nicely in these little quadrants here. So let's see. Let's transform these guys. So we're adding 3, subtracting 2. Oh, I did not mean to put a negative there. So we're adding 3, subtracting 2. So 3.5, 2, 4, 0, 2.5, negative 6. That's okay, that's off. And then adding 3, that's 2, subtracting 2, negative 4. 3.5. Now I'll use pink, I think. 3.5, 2, 4, 0. And so that looks decent, maintains the same shape inside those asymptotes. And now we have 2.5, negative 6, which is just somewhere down here, and 2, negative 4. That seems to fit as well. And this guy would just keep going over there, and then it would shoot down like so. Not too bad. Just a friendly reminder too, and hey, why don't we just actually check this out? I wonder what Desmos has to say about this graph. We haven't used that too much. So let's check it out. 2 divided by, so y equals 2 divided by x minus 3. Didn't need the brackets there. X minus 3. And then we were subtracting 2. So how did we do? Comparing ours with theirs, it's looking pretty good. Asymptote at 2, asymptote at 3. Yep, seems pretty solid. And if I were you guys, I'd be checking everything with Desmos, especially if it's being submitted for marks. All right, can you guys try this last one? Now, there may be some talking points about the values for A and K, and there might be a couple different possibilities actually, which we've seen before. We've already established earlier in a warm-up that sometimes say a horizontal compression can actually simulate a vertical stretch and vice versa. So I'll see what you guys come up with here. You can pause and unpause when you're ready. I'll assume you're ready to follow along. So here we go. Let's pick off D and C, opposite. So 3, nothing added on. That's always nice. It's always nice to see zeros for C and D and ones for K and A. Okay, so I think the most natural fit for this one is to say, okay, I'm multiplying the x by 2. So 1 over k is 1 over 2. And the entire rational function by -1. And this will work. However, maybe I'll just put or, because I have space up here. You could think of this as instead having a k value of 1, so that makes 1 over k equal to 1, and an a value of -0.5. Those are both valid ways of interpreting that. I think the easiest for you guys, and I think what will be most natural for you guys to visualize, is the way I set it up in the table. But yeah, there are sometimes more than one way to describe the transformations. But as we know, sometimes that can result in the same graph. So that's not contradictory or anything. But let's use my values here. So we're having the x values, and we're switching the sign on the y values. Okay, so this is going to be pretty squishy. That's okay. And -1, 0.5, and that should just be -2. Having the x and flipping the y, -1, -0.25, and 2, and -0.5, 1. Yeah, this will be a bit squishy, guys. That's okay. 0.25, -2, 0.5, -1. So you can see it's definitely squished closer together. -0.25, 2, so something like that. -0.5, 1, something like that. And it got squishier as well. But again, the asymptotes haven't moved because we've only stretched and reflected. And now let's translate. This one's an easy translation because we're just adding 3. And remember, our asymptote moves too. So if we're moving things right 3, let's just move the asymptote right away. That'll help us give shape to our graph. C is 0, which means we're not shifting our horizontal asymptote. It's still there. So drawing those in can help you give shape. So adding 3, 3.25, -2, 3.5, -1. Careful here, 2.75, 2, and 2.5, 1. 2.5, 1, 2.75, 2. Well, I guess I've been using pink for my final. A little hiccup there, that's okay. There, right there. Seems to line up pretty good. And then 3.25, -2, and 3.5, -1. And that seems to fit there too. Nice. All right, guys. So yeah, what we done today is, and hopefully you got this summary down. So this is a good summary of all the transformations. And today we combine them all. So we need to be able to pick off those 4 parameters. And once I think that's done, I think if we use our rules for finding image points and use a table like this, I think these problems can be pretty manageable. But I need you guys to be able to pick off base functions and original points as well. And eventually we're going to try to move away from having a setup like this. That's not always going to be the case. And I'd like you guys to be able to pick off the transformations, visualize what a base function looks like, and visualize all the transformations. But for now, got the the scaffolding. And if you're sketching any function at home, maybe making a table like this in your notes can help you out a little bit. As usual, keep Desmos open. It's a really good tool to be checking this stuff. And if you're in my class right now, I may tweak this set of practice problems. I might add one or two, take away one or two. We'll see. But yeah, until I see you guys next time, hope you're having a great night, staying well. We'll see you soon.